All right, so with an association claim, we can ask questions about the validity of the association claim, right? The two most important validities to ask questions about are the construct validity and the statistical validity. We can also ask questions about the external validity, right? How well can the association between the two variables be generalized? Remember, internal validity is for causal claims. So questions about internal validity are, can we really make a causal inference from an association? But for association claims, these two in particular are important: the construct validity and the statistical validity. And the construct validity refers to how well was each variable measured. We have two variables that go into any association claim, so you can ask the same set of questions for each of these two variables, and overall the construct validity of the claim depends on the combination of those two variables, right? So ask about the construct validity of both variables. How well was each of the variables measured? Does the measurement for both of them have good reliability? Is it measuring what it is intended to measure? And for each variable we can ask, what's the evidence for the phase validity? What's the evidence for the concurrent validity? For the discriminant and convergent validity? If you don't remember those, look those up, because you need to remember, right? This continues to be relevant. So to go back to the examples I gave, for each of these variables we can ask that same set of questions. Right? What's the reliability of this well-being scale? What's the construct validity of that well-being scale? Again, construct validity, you remember, is how well does it measure? Does it truly reflect the construct that it's intended to measure? And we can ask that same thing here, right? How reliable is this measure? We can do inter-rater reliability, for instance. And what's the construct validity of this measure? Of course, in order to answer that, you would have to read the paper and study how they actually measured that. And the same goes here. What's the reliability of a measurement of how much time do you spend on average sitting? What's the validity? Well, construct validity, I suppose, is fairly straightforward, right? But you can ask that same set of questions, and also the same for the medial temporal lobe thickness. Side note, that was one of my first jobs out of college, was work at an anatomy lab where we took brain scans and measured the thickness of different brain structures, and I was one of the raters, and there was another rater. So I spent my day tracing particular brain structures, and then there was another person who did that, and then we measured the correlation between the two of us to get inter-rater reliability for the measurement of thicknesses of different brain structures. But yeah, you can ask this whole set of questions for both of these variables, and the construct validity of the claim, right, this variable is associated with that variable, depends on the construct validity of both of the variables. Anyway, moving on. When we ask questions about the statistical validity of an association claim, we're basically asking about questions about the strength of the relationship between the two variables, right? The strength of the relationship. So how big is the correlation coefficient, the R? How precise is the estimate? We can ask questions about whether or not the relationship has been replicated. We can ask questions about whether or not there are outliers that are affecting the association. So outliers are measures that are far outside the range of the other measures. So if we were to have a measurement that would be like one measurement that would be here, right? That would be considered an outlier. Outliers are possibly problematic because they may not be representative and may represent error measures. So if there are outliers in our data set, what do they mean? Are they just, is that just how our data is distributed, or could this be an erroneous measure? And more importantly, if there is an outlier, could it be affecting the association? But let me look at the strength of the relationship first. Right? The strength of the relationship refers to, well, the how closely two variables are related to one another. Psychologists and statisticians often refer to this as effect size. Right? And we've already talked about this a little bit. But both of these two graphs here display a positive correlation. Right? There's a positive correlation. This is a positive correlation as well. However, in this case, the relationship between these two variables, whatever these are, is stronger than the relationship between these two variables. The R value, the correlation coefficient of this graph, is greater than of this graph. It's higher. It's closer to 1. Whereas this is still positive, but it's not quite as high. So it's closer to 0. Not quite 0, right? It's still positive. Now, generally speaking, larger effect sizes tend to be more important than smaller effect sizes, right? This is usually more impressive than this, and perhaps more useful than this. But that doesn't mean that small effect sizes are unimportant. The book gives several examples, right? For instance, it's been found that there is a positive relationship between the personality trait agreeableness, right, which is how warm and friendly and cooperative you are, and the degree to which you have enjoyable social interactions. But that's a small correlation coefficient. It's only 0.07, right? It's a very low positive relationship. But consider that, you meet hundreds of people each year, right? So 0.07 is not insignificant out of hundreds of interactions. 0.07 is not insignificant, right? That's still a satisfying amount of people. Right? So small effect sizes can compound. Another example that the book mentions is a study that did that studied the effects of what's called teaching a growth mindset about intelligence. Right? So teenagers were given a lecture about having a growth mindset. Growth mindset about intelligence means that the mindset that you can learn to be smarter. Right, that intelligence isn't fixed, but if you're dedicated and self-improve, and you can learn to be smarter. And that study showed that teaching a growth mindset to kids and their subsequent grades has a 0.05 correlation coefficient, which seems really small, right? 0.05. However, the degree to which it boosts your grades is only tiny. But keep in mind that if we do that to all teenagers in the United States, right, that's millions of kids, then you boost the grades of tens of thousands of kids. So small effect sizes over large populations or over large numbers actually can have important effects. So point being is that whether a large or small correlation is important really depends on the question that you're asking. It's not always the case that larger effect sizes are more important. So yet another question that we can ask is, how strong is my correlation coefficient, like compared to what? Right, in the 90s, a guy called Cohen proposed that weak correlations are about 0.1, moderate correlations are about 0.3, strong correlations are about 0.5. With the estimated average correlation coefficient in psychology studies around 0.2-ish. Right, which doesn't seem very high, and it's not. People are complex things, and there's a lot that goes into our behavior. Keep that in mind. And some researchers have indeed suggested that too high correlation coefficients in the context of psychology aren't particularly reliable and maybe from biased samples.